Alrighty, I think we're up. Show you the system. How? How would I do that?
That's yes. So we will be scoring that, but we should first decent help this school. Anyway, cool. Thank you very much for that.
Let me just figure out what I'm doing here.
And so in today, just going URL shortly like that. Is there anything else on that sort of stack? Yes.
Okay. Let me just get a demo page up in the development. No, I'll show you the actual production version. This is really quite ugly because what I have to do is, because I don't trust the security of the system at the moment, I made the assumption that the network was secure. And so now I have to VPN into the network to be able to access the production server.
So
yeah, that's
yeah, VPN is right to manage. Have you been keeping up with the React server components?
No, I have not. What's the deal there?
So this is the new version of React. Like they're responding to all the frameworks that are starting to be full stack frameworks. Like
Right.
they're starting to build more tooling around like communication between client and server. The React team's response has basically been to extend the idea of components so that components can like live on the server or on the client or on both. So basically think props passing like is your network protocol.
Well, that's a bit heavy.
Yeah, it's weird. I have a sneaking suspicion it'll be very popular based on the amount of like fuss that it's kicking up on Twitter.
Okay,
but it's worth it.
I'll look into that.
Yeah, I think it's worth thinking about because you want React to be the UI layer, right?
Right. Let me share a window now, and then we can get into the nuts and bolts of things. Can you see this page clearly?
Mm-hmm.
Okay, so this, as you'll notice, has an SSL cert on it. Now, I did bad things. So the page here is hosted on GitHub,
Right.
using GitHub Pages, and it builds out of the monorepo by, when I manually trigger it, it takes a copy of the CRM GUI package, pulls it down, runs the build, pushes it out to the GitHub Pages page.
Right.
So it's, my automated builds are not the production version that the clients on the site see. When I'm comfortable with it, it's still a package within the monorepo. When I'm comfortable with it, I run this build cycle and it produces a new page for the clients. under the hood, what I did was I ran the server on, let me drag the server over for you. This is the monitoring system I've set up for monitoring. This is my dev environment. This is the production environment. And what I've done is, like, I run this on a local machine, and I can interact with it using this monitoring tool, where I can get the disk usage of the database, currently sitting at 5 megs. Whenever I do imports, I can see the customers per second rate, which normally sits at around about 50 customers per second when I'm doing a pull. The target functioning number of customers is 20,000 in the system, which is far in excess of what the customer needs. If they had 20,000, it'd be great, but the numbers are more like 2/3 of that.
When you say customers per second, you mean that's like number of active users on the system?
Number of customers being managed. Active
Right.
users is only the admin staff at the moment use the app.
Right.
One of the future features that's coming is to provide a customer portal so that the customers can access their own data. And that, because the way I designed it was each customer is a blockchain, I can, when the portal loads up, I just give the customers their own blockchain and the permission to access it. So there's no real difference between the data, the app logic, and the UI components that I use on the admin app or the customer-facing app. It's all the same thing. So what I really wanted to show you, though, was more about how the thing got made. And
Sure.
I'm sorry to be jumping around a lot, but this is the first demo I've done, right? So this particular model of how I do stories worked out amazingly well. So I'll just open up a couple that show various scoping levels within the app. So this is the story that shows the top level app, like this is the entire app. And these two lines are the key lines to the whole system. The fact that I can run the engine with a syncer component that focuses on a particular path within it and keeps that synchronized and passes that as a prop down. It means that when I'm in Storybook, I am running the entire system end to end. So I have but it's not just the whole thing. It's like, as I can show you in these components, this is like a narrow band going into it. So it's like it's end to end thin slice. So like, for example, here, I've used this unwrapper part to actually drill down through the logic to get a very specific thing out. In this line, what I've done is I've installed a sub-covenant. So the root covenant is CRM. It has a bunch of nested covenants within it, like routing, customers. It's got different covenants that have different app logic in it. I can install just one specific covenant and then pump that into the specific UI component that's designed to interact with that, and then test that in Storybook while I'm twiddling the server logic and the persistence logic, as well as the UI logic as a complete end-to-end component. And my feeling is that feels a lot more durable, because when I put it in the app, I know that it runs the whole width of the app.
So when you're zoomed in on one piece, it's still booting up all the satellite of like other things around that piece?
No, only things that it needs. So, for example, I've made this init prop that I pass to the engine is a series of commands that will be executed. The array indicates the sequence of commands that will be performed. The object, if I supply multiple keys to the object, it indicates I want to run the commands in parallel. So just to help the loading speed, I can run them. If I know that they're independent, I can fork and do them all at once and then return. So this is basically installing the covenant and then deploying some fake data by using the covenant actions to add that data in. And then you start playing around with the actual UI logic when it's running in the exact same way that it will be in production, because production is just an assemblage of these components. So it sort of gets rid of that translation layer between the back and the front.
You don't need a stub, like.
Nah, right? you punch straight through. You punch straight through the networking layers, the database layer, and the app logic layer, and just worked on that cross-cut slice.
Yeah, it's really cool.
It felt way better, man. Like way better. So when I run the actual app, the only difference between the storybook and the actual app is the networking parameters that I pass the engine. So here, this is the GUI that's being published. This is the exact same, it's basically the same thing as the storybook, right? But all I did was I supplied some addresses, some multi-addresses, which are, I get those out of here. So I can query the running service and I get like this is the libp2p multi-address for connecting to it. You'll notice it's WSS. So I've generated some certs, put them locally, and then did something you shouldn't, where I set a public DNS record to resolve to a Class C private address. But it works. I mean, whatever. I mean, there's so many other things I should go to hell for. So in there, this is the prod app. All I've done is told it that I want to mount something remotely. I want to mount a remote chain ID, and here's the addresses of the peers that you should use to get a hold of that chain ID. And then when I fire it all up, this is it running. And so I'll show you the load process. It makes its own blocks. It does its own mounts. It's firing out a WebSocket connection to the server to pull down the chain that I just mounted. It mounts it progressively. So as it comes in, it mounts and renders what components it can see. It probably loaded a bit too quick to. I'll try to show you that slower. In the last few weeks, I've tuned this a lot more. I just haven't deployed that version yet. The tuning I did makes the loading be much more progressive. Oh no, it's too slow. You can see it more when there's 10,000 customers and the customers kind of dribble in.
Right.
So each one of these is a chain. The chain is running on a different computer to what this browser is on. I'm going to add a fake customer here with the plus button. When the gray, and that was the addition of a new customer. So that's how long it takes. Just sort of not. I thought that was quick. Anyway, I'll do it again. So I'm trying to generate customer number 103 here. you can see the progressive load as it came in here. It knows there is a customer, doesn't know what it is. Eventually the pulse resolves and now it gets back customer 103. The mapping component, each one of these sectors is a blockchain. And this is an old but stable version that doesn't have the button that lets me do the point and polygon testing to add all these customers into these geographical boundaries. But probably when my next deployment goes in, maybe like tomorrow, then you'll be able to see lots of map markers that correspond to the customers that are here. Yeah, that's about it, actually.
I'm actually kind of in awe. Like, what are you using to view the data in the backend right now?
Sorry?
Like, do you ever need to explore the data the way it's like going in? I'd love to. Are you still using the IPFS like?
Well, yes and no. Hang on a second. I think I can give you what you want. So Interpulse is loaded in the browser window, and I have attached all the shell commands to it.
Mm-hmm.
So what I can do is go like I can do ls on that customer I just made, which is 103. Probably want me to quote it there. And then I guess my ls command doesn't work.
Well, it should be there as M.
Shouldn't it have given me the result back? Okay, so here's the state of that chain anyway. So I can explore the data in this way.
Okay.
If I want to explore customer 101, then
Autocomplete is not your friend.
not my friend. So yeah, that's like the state data of that particular chain. Is that sort of what you mean?
Mm-hmm. Mm-hmm.
So I didn't actually go through the rigmarole of loading up DOS, which is the actual terminal that gives you these commands, just because it became quite difficult to interact with the material UI components that expect to be full screen and then also have a terminal. So I might put that in later. I haven't really needed it so far, just because in Storybook, I've just been interacting with it in Storybook. It's quick enough that I can actually turn on logs on and off if I want to explore the data. So it's not like I sort of sit there with doing data analysis. I just reboot the whole system and then look at it that way because it's quick enough to do so.
Yeah, I mean, I'm actually very surprised how fast it is.
It was really fast. So I managed to get the block time or the pulse time down to, in some cases, as low as 9 or 10 milliseconds to make a pulse. And I've, along the way, have spotted ways to make that go even faster. I do believe I can get that down to sub 1 millisecond.
What? Doesn't it take longer than that to hash it?
No, actually, if you're taking advantage of the previous hashes, the hashing is actually very minor. The translation between JavaScript object and binary form takes quite a bit of time, and then you hash the binary form. That's very quick.
Right.
signing is 1 to 2 milliseconds to sign it, but I believe I've in the change log that I sent, I've put in an proposal there to sign only the app root. So I think there's a lot of benefits from actually having all the children treat their signature as actually a piece of app root. And so in that case, you can roll up all these changes into the top, and the you only need one signature. So if you're doing multiple updates across the complex in parallel, then your signature time is basically negligible.
Right. Is that enough?
That's not really the main speed up. The main speed up that I want to add is that if you have a schema for your data, first of all, I can translate it to remove all the keys from the object and just only hash the values. And second of all, if you have a schema, you can do stringify a lot faster if you're just doing string additions with pre-existing keys, as opposed to trying to make an object and then stringify it. So basically, I think I can get that stringify plus hash time. Were you asking about the data showing in the console?
Mm-hmm.
That is entirely generated using Faker.
Okay. Okay.
Yeah. So this is I mean, these are the logs from the app. So this is like each block that the server made is being streamed here. But see these numbers here, like I can add 100 fake customers. Like here comes 100 customers. And I can, so I can, right? Like I can control that all from the monitoring dashboard, which is pretty cool. So yeah, when I go back here, I'll have an extra 100 customers come streaming in soon enough at some point. There we go. Here's 100 customers, and they loaded progressively.
That's incredible.
Yep.
Are they loading like according to the viewport on the screen?
Sorry?
Like, is it a virtualized display? Like, is everything loading according to what's visible right now, or is it just
no. So there's I supply the data as unvirtualized, and then the table component deals with the virtualization of it.
Okay.
Yeah. So that's these controls I made let me do a lot of things like hard reset. Very useful. Probably take that off in the once we're ready to test with real data. So stats is kind of an interesting one. This is where I can get the bit swap statistics. What's been sent over bit swap, how big the repository that stores the data is, things like that. So
can I see the two things? One, where are you configuring PM2 here in the code?
Yep, sure.
And then the other would be like storybook. What does your storybook look like now?
So this is the PM2 module, and PM2 has a way of running that lets you install modules off npm. So it doesn't actually run an app on site; it runs a module that it installed, and the configuration for it is stored in this key in the package JSON.
Oh wow! So how are you putting those actions on it?
Those actions are in there from the entry point to the module. I import PMX in that module where I configure what the dashboard will show. And then this is where I boot the engine. I check the certificate expiry times, add some environmental variables, do some initialization if it's a virgin engine, things like that. And then I just go PMX action. And then
this is totally where you should put the terminal.
I know, but I can't. it's a bit of fluffing around to have because these actions are like request response. They're not like REPL. There is a form of REPL that I can do here. Look, I'll make a note of it. I'll look into it. That is a good place to put the terminal. I hate you for saying that because that's like more work, but
it can't be that bad. I mean, like these blocks, they have only specific ways they can behave. You can't just like push an iframe into it.
Sorry?
The block.
Oh yeah. No, you cannot push an iframe into it. Yeah, that's a good point though. That would be the perfect place for the terminal to be. There is a type of action they have which is it's a long running action, so it allows you to interact. They call them scoped actions, and it allows you to interact with the process. So I think that's probably more what I want. Maybe I could just make a web page that just loads the terminal anyway.
I thought that the whole thing with HTTP2 is that like a request response is a WebSocket now. Like if you just don't close the request and you keep sending data back, it's exactly like a WebSocket.
I didn't know that about the protocol, but it's more around the design of how PM2 have set this up to work and how they've made this the way you connect actions in is really just this one callback, this function with a callback. So you can't really do a thing like over and over,
like an async loop in here, right?
Yeah. So like you can call the callback once, and that gives the result back to the UI. But I'll look into the scoped actions. And sorry, your other question was
the running storybook. I just kind of
the running storybook. Yeah, sure.
You're a machine, Tom. Like I don't know how you get this much.
Dude, I've been working my ass off. I've been working my ass off for years, right? Like it's been a long fucking time. Okay, so this is the last published storybook. You can just I'll send you the link so you don't even have to type, and you can poke around at it yourself. And then I've always struggled to actually find the direct link to the storybook out of chromatic stuff, but here we go. I'll give you a link to the storybook directly. Okay. Yeah, and the code base for that is found under WebDOS. So I'll send you a link to that as well, just for completeness. Okay.
So everything in here is actually like cut the same way. It's all like components in the app in the storybook, and they're all running on live systems.
They all boot up the engine. They install a focused component, a focused covenant that only relates to their UI logic. Some of them require multiple covenants that are tied together. Some of them require fake data, some of them don't, but they are all genuine covenants. And then the storybook states, so the different stories are exercised by manipulating the covenant state to be able to provide the UI changes to know that the UI responds correctly, which I don't know the word for it, but that has surfaced more bugs in my server-side logic than any other form of testing, because I'm like with it so much, right? There's just because the UI hits it at all different angles with all different conditions. Those conditions appear more than my testing in the blind does. Right? Like command line jest testing, I can't see what I'm doing. I'm imagining it in a way.
Yeah, I read this advice a long time ago that really stuck with me, which is make illegal states unrepresentable. Meaning, like, you shouldn't be able to have something in your view that can't possibly exist in your backend, right?
Right.
And I imagine that's probably what you're seeing the effect of here. Is like,
yeah, but it's that, but it feels like it feels like I'm in control of the persistence layer, because if I fully control the UI, it feels a lot better to work with, like a lot better. It's fast, all quick to load. There's no distinction between the production environment and the storybook environment, really. Like when you look at that app, the app story is identical to the production page, except for I'm saying it connects to a chain that's hosted on a different computer. That's all.
right. So what would it what's a feature that you're adding to this app right now? Let's step through like the process of how you would find the right place and start adding that feature, I guess.
Okay, so I've split features into platform features and application specific features. Right now I'm working on a platform feature, which is the synchronization speed when the number of customers gets above 1,000. Was that what you were asking, or were you more asking an application specific feature?
I think like let's look at app level features first.
Okay. So the next feature I'm trying to add is under, I need a button on this page, the routing page. I need to add the functionality to run this update button, which is represented by the covenant in, let me just pull up the covenant. Under the routing covenant, and the action I'm trying to pull in is the one that triggers this switch statement update.
Right.
And so, first of all, I drilled down to this particular component. So this app page is made up of the routing subpage, and then the routing subpage has this button, which is the routing speed dial button. And so I came in here and was like, add the update. Inside that update page, is this answering what you were?
Yeah. I just kind of want to see what does your change process look like right now in
Okay.
an app?
All right, yeah, so I added the update button, which gave a callback to a function, which was this is the routing speed dial story. It is one of the artistic choices I have to make is, do I pass down the handle on the chain, or do I pass down some callback and then handle it higher up? Routing speed dial I considered outside that boundary, so I passed down to it simply args that include actions to be done. Then it lifts things back up. So if I go into the component of
So
that.
they find all these rules, and in order so that and
So this is that actual component, and the args that it expects to receive are these callbacks. So this is something that's outside of Chainland. These are rare. These are rare pieces. Most of the time, it's chain all the way down. But just because I don't want all the actions, and I want to add, like, decorate them with extra names and stuff like that, and icons. That's why I chose to make this a leaf, or outside of the chain boundary. It is controlled by this routing component. So I imported it here into the routing component, and then when I create it, I pass down its this is the part that I haven't done, but I'll be making this when I get the crisp. I can grab the actions out of the crisp, and so I do like, this is the change directory command, which is used to, the change directory command gives me this functionality, so I can switch between these. That's issuing a CD, so I basically play with it and turn on the logging and stuff, and then I can see that, like, it did a change directory in the shell chain, and then I poke around with it in that way.
In a very real way, this UI actually is the terminal.
Yeah, that's the thing. That's why I dropped the terminal, because I'm like, it's so closely bound that it does. I completely lost the need for it, which is a weird realization to have, because I'm like, well, as it turns out, you want the terminal because you've been building server apps that are so distant from the UI components that you need this other UI to interact with the server data. But here, they're the same component, so what's the point?
no, we'll pull the data down.
So this is the function that calls update, that I pass down to the routing speed dial component, and on update is simply digs into the actions object on the crisp and calls the update object, which was automatically generated from the schema definition in the API for that covenant. So this is the update action within the covenants API, and these are the properties on it. That function is a generic function that I provide in the engine that it parses the schema, and then any args you give it, it matches them against the schema and then generates the object that you meant if you provided the correct parameters, and then dispatches it into the engine, and then awaits the result for you. So basically, I can list all the actions that are available at a particular path within the engine, within chain complex, and then I can also get all the parent actions that I would have had access to, like CD, all that, as well as the local covenant ones and the overridden ones that override some of the higher ones. Yeah.
And that's what's on the actions object in the
crisp. In the crisp. So this particular crisp will generate for me. We'll have update, approve, and it will also have CD and all of the parent actions that were passed down, like the paths, like how the path works in Linux. And then I just call them as a function, with or without parameters. So when I make a new action, it's actually I'm I started writing by making the storybook, punching the button, and then working through the covenant to get the covenant right, because the feedback loop is that fast. Like it basically, I hit save on the covenant file. The Vite server detects that change, reloads the storybook. The storybook then deploys the new covenant in that focused element. Now I have the new logic and I can click it, and it all happens sort of before I can alt tab back into the browser. The new logic is available for me. So I think things have changed here. Now that I've started working like in this model, as you point out, the terminal's redundant now, but something else changed. Like it's just there's like a step we get to miss now. That was a traditional deployment step. It's almost like I don't need to test the server side nearly as much. And really the testing focus is the front end. Because if I'm building the back end in response to each component in a storybook, do I still need to even build the back end at all if it sort of fell out the side of having built the storybook?
Have you ever run into a case of like impedance mismatch between front end components?
Can you give me an example of what you mean?
Yeah, so like what I've run into in a few cases running teams is just two people are working on two different front end features, and they're using basically completely their own like data structures in their head that don't really match either each other or what's in the back end currently. And then when you go to try and integrate it, it's like a nightmare to integrate, right?
Right. Okay. So in terms of the business plan for where I want to get to, this deployment proves to me two of three things that I need. It proves to me, first of all, income. Like it proves that I can make something that someone will pay for. The second thing, I believe that it provides enough evidence that I can prove profitability, because I can look at my experience with this and say I can for sure build an app faster than a conventional app developer can, just because of this this way of working. Now, I don't have a profitability proof in terms of like this was a complete stranger and I charged them and this and that. It's more like I have evidence that I can feel confident in that it is profitable because it's quicker. The third thing I need is the proof of scale. Can I get multiple developers to productively work in parallel on an application that's either too big for a single person, or that I'd like to go faster than a single core? So that part I don't know, and that's really the main thing I want to test with you. If we can try and do things that overlap, do we collide or are we productive? And my initial theory is that because the back end is a requirement of the front end component development, the conflict in logic will surface quicker as the developers try to merge their branches in, and they will rapidly realize that they need to reach consensus between each other as to the API and functionality of this covenant.
Right. I guess the other thing too is the back end. You'd see there would be like a it's not like a database schema where you're never going to get a merge conflict with it, right? It's like there would be a merge conflict right in the chain code when you go to merge with somebody.
Yeah, you'd hit it immediately. You'd hit it. You'd be like, whoops, that's my model's different. And then you'd have to slow down a bit because you'd have to talk to that other person. But once you'd sort of agreed on a stable thing that you can both use, then you can speed up again. And I think that whilst that is slower than both operating independently, that is a speed up over a conventional app where you wouldn't realize that difference until later.
Yeah.
And like
Right,
a covenant used by two people is definitely going to be better than a covenant used by only one.
Yeah, I guess, which is what you would like hope for from software. Right?
Yeah. And then the thing I'm really excited to try and get a handle on is, can we export these modular durable components and have them pulled in independently? Like, can I pull in just that story from somewhere else and make use of it?
Yeah, I suppose it's about how clear like that story's dependencies are. It's like chain-led dependencies, right? Like
So
it
that,
sits in a context inside the app structure that it requires to be there to communicate properly, right?
sometimes some of them are independent, and others need a small, others do need something else around. So here's
You've made components in here that don't talk to anyone.
Yeah, like so for example, this is the routing component. It has a dependency on the customer's collection. And so here is the line where it goes and gets access to it, because you can tell it where that collection is located on the fly. So during testing, I can place it in a different location as it would be in production. It might be on a completely untrusted complex as well. It doesn't really matter from the point of view of this object. So an example of a covenant that has no dependency on another one is the customers one, where this is basically the CRUD thing, and it's like,
Right.
it just, everyone reads from this thing. You can update these components directly. No one else needs to touch it. It doesn't need to know about anything else.
Right. So I assume the way you've structured this is customers is like the table, and then customer is like the row on the table.
Correct. Yes.
And all of the interaction is marshaled through the table, is marshaled through the collection.
No. All of the collection level operations, such as add, delete, those are managed through the collection. But all of the read and update operations are managed by the individual chain of that customer for the purposes of parallelism. So you can you read it all independently, and you write to the chain directly. The chain is in charge of its own logic, so they all share the same covenant, and that covenant does like schema checks and other logic checks and things like that. So it's controlled in terms of the covenant that gets deployed to it. But as soon as possible, the general principle is, as soon as possible, push out the dependency as far to the edge as you can, so that you can access as many customer chains as possible, all running across different engines with minimal slowdown.
Right. I see what you're saying. Is there any task inside of the CRM that I can do?
I can't think of anything right now, just because there's a lot of stuff that I didn't really make clear for another person coming in to make changes. How I'd intended it to go was that the CRM would act as the reference, and so when we make the next thing, we'd look back at the CRM and be like, oh, because the thing is, I keep having to change what I would recommend as the best way to do things is on occasion, and so we need to do lots of different things to learn about how they should all be done.
I'm trying to figure out where I can start to contribute. I think I don't know if you still need the iPorn stuff done.
Absolutely, I need that. But I don't know if that's the best place for you to contribute.
It's kind of both. I think the way you seem to be working is you're flipping back and forth between the application and the engine all the time.
Yeah, all the time. Yeah.
And I see that it kind of looks like that might actually be the best way right now.
Right.
If I could figure out a way to do that, then maybe
I think the thing I would most appreciate feedback on is for you to use the storybook to make a different type of app, and then talk to me about what you want it to do, how should it do it, why is it not working this way, how can it be faster, that kind of thing, because that's really what I want to get right, is the developer experience here. And I think it's heading in a really good direction, but there's always rough edges here and there that need to be smoothed.
I'm always surprised by how different people's mental models of things are.
Yeah, no, right.
And that's probably the piece that I fear the most, is I'm going to jump in and I don't understand the way that you think about things, right?
Yeah, but I think we both got to just deal with that, because two people with a shared model is way better than one, and is more likely to be easy for a third.
It's that meme, it's always the second person to start dancing that causes everyone to dance, right?
Yeah, exactly.
The first person just looks like a maniac.
Yeah, I know. So the other sort of major directions I need to take is I need to run in a tablet format, so on an Android device. That's the next sort of major shift for the engine. I need to get the Dreamcatcher apps up, like the App Store, the way of doing issues, the way of taking payments. All that line of things needs to be done. That will all be done using the storybook method. So that's sort of why I'm so focused on getting the storybook methodology going, is that this is the tool to get all the other stuff done in the smallest amount of time.
Is it a good idea to start working on one of those then?
Maybe, yeah, I think so. It couldn't hurt.
Issues seems like a pretty easy one, right? It's basically, if you were doing it in a database, it would be one table plus users, right?
Yeah.
Or two, I guess.
Everything's different when you want the user to own their issues and the project to co-own those issues, where the project is an independent unit.
Right. So you have project, you have user, you have issue, and you have comment, basically.
Yeah.
And
right.
But then
actually, you're right. I think it is simple. It is simple.
But the parent-child relationships can be weird, right?
It's the only weirdness is this forking. Forking an issue is not something people are used to doing.
Well, do you fork an issue or do you fork a project?
No, you can fork anything. So you can fork an issue, and then it's kind of, the project always runs a filter. So the forked issue can either be, you can kick out the original if it was blasphemous or something, or you can kick out the fork. It's sort of, the multiverse model is meant to allow, depending on who you think is valid, that's what the project looks like to you. You can go around and grab all possible views if you want, but my expectation is there'll be a lot of garbage in there.
Yeah, other people suck, basically, right?
Pretty much, right? So
no, that's being too glib. I think actually, the more I think about it, the more I think that project might be the can of worms in that structure.
well,
Project can be
maybe.
pretty simple. It could just
Maybe.
be like,
I know. The reason why all this is sort of delayed is because covenants are not properly done, because the output of a project needs to be a covenant, and a covenant needs to be able to be pulled into a project. But right now it has to go npm project chain. But to be able to store covenants on chain is a bit of a doozy, really.
is it? Feels fun to me. Except I guess there's like all these really weird like change related problems, right?
Well, the models that we currently have within GitHub and npm are compromised models. They were models that were chosen because of convenience, possibility, and then later on the business incentive to centralize. To look at pure utility of what that model should be to allow easy contribution with attribution is more complex. I think that a first pass at it is better than any perfect theory.
Does a project really need to? I guess what my question is does a covenant really need to be an object in the system if the code base is an object in the system?
Yes and no. The covenant.
Commit, then you have a good, like you have a build system that like always produces the same build artifact every time. Like
most languages do not provide deterministic builds. So
can we
yes,
use
in
something
theory.
like Nix?
Like what? Sorry.
Can we use something like Nix?
What's that?
It's literally deterministic builds.
Whilst I love a good deterministic build, I don't think it actually matters because because what we really need to do is to be able to get a public chain functioning. And the reason why is because a public chain is basically a front for selling computational energy.
Right.
Once we can do that, what we want to do is create projects that consume computational energy for a price. So useful things that take compute, because we can sell that and we can tax that on the way through. That's what I need to get going. You're like, okay, our primary goal here, or the thing that we bring to the market is a developer model for how to program durable systems that have enormous scale, that operate very cheaply, and can be offline and require very little configuration. To achieve all those things, we need this public chain that is like, basically I should be able to go npx Dreamcatcher demo straight away, and then I'm like, one more command, publish. It goes to the public chain running on donated resources if you want, or purchase resources if you need something serious. But we need to generate the computational load on the system, because that's where the money is. That's where the adoption is. You need that. as an app developer, as soon as you come to deploy time, your problems start. Like making an app in dev it's pretty easy these days, I think. Making it run in prod seems sort of harder than ever, especially when you need to have all these like extra things. So that's what I want to get to. That system requires a publication system. Like, how do you publish? How do you publish artifacts reliably? Now, why I brought that up in terms of the build system is that I don't think it really matters whether we have deterministic builds or not, because if we're selling the compute resource that was used to generate the one-off build and then offering it as, hey, we ran this in a trusted environment and we stake our name on it that this is the output we got.